Hi, this is my first video to YouTube, and I thought I would like to share my knowledge and passion for Python programming by this series of videos called Leveling Up Your Python. In this video, suitable for people who have some experience in Python programming, I would like to share some tips which I think would benefit everyone. So my first tip is to use Doctests. Now, why use Doctests? Doctests actually help us specify the intended output of our functions before we start coding. An important part of programming is actually planning, not writing the code. Okay, so by specifying the intended output of our functions, we ensure that we are coding to our specifications. Doctests specify how clients of our code should use our functions through examples. And Doctests shorten development time by actually automating testing and rewriting of code. Beginners tend to write code in like Jupyter notebooks and test the output of their functions interactively. So they write the code and then run the Jupyter notebook and see what is the output. If there are mistakes in the output, they go back, rewrite their code, and then run the cell manually to get the output again. This is a time-consuming and boring process, and all this could have been automated by writing Doctests. Doctests are written in the documentation string of your code, so they are near to you when you're actually implementing the particular algorithm and when you are writing your function. So what is a Doctest? Doctest is actually a module in the Python standard library that allows us to write quick tests in the function's documentation string. So you don't have to write a separate module in order to write out a test, just like the unit test module requires us to do so. Doctests are a quick and easy way to actually write tests for your Python functions. So I thought as a demonstration, I would like to write a Doctest for the implementation of the Euclidean algorithm for finding out the greatest common divisor of two numbers. So just to give you an example of what the greatest common divisor is, let's say we have GCD, greatest common divisor of 4 and 6. The answer should be 2. That is because 2 divides 4 and 2 also divides 6. And there is no larger number than 2 that will divide both of these numbers simultaneously. So I want to write a Python function that will help me compute this value straight away. And you notice that when I'm writing this, I'm actually emulating the Python interactive prompt. And this is actually a Doctest. It is basically writing what would appear in the Python interactive prompt and its output. And later, when I actually run this function on the command line using the Doctest, it will detect such strings, run the Python interpreter, and actually compare the output with what I've written here. And so if the output matches, the test passes. Notice that I do not care about how I'm going to implement this function yet. I just care about the intended outcome. And this is the essence of testing. You really just want to specify the inputs and the outputs. And if the output matches what you expect, then the test has passed. So you use this to make sure your implementation is correct. Now, other examples of the function working properly would be one where we compute the greatest common divisor of 1 and any number. So when that's the case, the greatest common divisor would be 1. In other examples, if let's say we have the greatest common divisor of 2 similar numbers, then the GCD will be the same. So in this case, GCD of 14 and 14 will be 14. And lastly, one more last example. Suppose we compute the GCD of 4 and 9. notice that this has no common divisor except 1. So it should give us the answer 1. One more last one. Okay, the GCD of, let's say, 3 and 9 is actually 3, because 3 divides 9, so it must be its largest divisor. So that is a full documentation string, some documentation of what this GCD function is supposed to do, some notes to help us write this function, and the actual outputs that we expect from this function written as though we were running this function in the Python interactive prompt. This is the doc test. Okay, so now let's start coding out this function. So it is a function, so we use the def keyword to start writing it. I'm going to call it GCD as I have written in the doc test. And it takes 2 inputs, m and n, and returns an integer. So this is called a typing annotation, which is something introduced in Python version 3.5 and above. So I should annotate the inputs as well, which tells people that this function takes in 2 integers and returns an integer as an output. Typing annotation is not mandatory, but I would highly encourage it. And I would like to do another video in the future concerning typing annotation in Python. Alright, so let's start implementing this function. First of all, I would like to make sure that this function doesn't really care which number is larger. Okay, so for that, I would just fix that m would be the smaller of the 2 numbers, while n will be the larger of these 2 numbers. So with this line, we eliminate the need to worry about which should be the larger number. I can put in any order that I like, as long as it is 2 integers. Okay. Now next, according to the way the Euclidean algorithm works, and because of one of the facts that I've stated here, if the remainder is found by the larger number being divided by the smaller number, then the GCD of m and n is actually same as the GCD of m with its remainder. So with that, let's just find the remainder of the larger number being divided by the smaller number. Okay, this percentage operator is the Python shortcut for helping us find the remainder once n is divided by m. Now, to implement this first fact in Python is quite easy. So I'm going to use if the remainder is not 0. Then I would like to find the GCD of the smaller number and its remainder, which I know is going to be the same as the original pair of numbers. So all I need to do is return the same function, but now I put in m and the remainder instead. So this is an example of function recursion, which is a nice way to implement iteration. And finally, if the remainder is 0, which is sort of the default case, then we just return the smaller of the 2 numbers, which is m. Because once the remainder is 0, all it just means is that m divides n, and therefore, by what we have written here, in this example, the GCD is by default the divisor. So with this, we have finished writing our function. And we would like to test to see that it works. So I save this and go to my terminal. And I could call up the Python interactive terminal and start coding and start using the function to see whether it's correct. But that would be tedious and takes time. The faster way is to use the doctest module, which I can call using the Python with the Python m flag. and typing doctests, which would mean I'm going to run the doctest module as a script with gcd.py. This is the function that I'm going to test out. And if I were just to run this directly from the command line, I will not see any output, which is what I want. It means everything is working perfectly. But it's probably not a nice thing to see when you're doing this for the first time. So I'm going to put the flag V for verbose. This will give more outputs to the testing, but it's not necessary. So let's run this, and we see that I've run 5 tests in 2 items, and all of them pass. So I have no failures. So test pass. And we can see that for each of these functions, what was expected and whether or not it passed. And we can see all the 5 tests. That means all the 5 prompts that you see here worked. Alright, this function worked. So everything is okay, and we can keep on developing if we want to, and every time we finish changing some aspect of this code, we can rerun the test, and it's much faster. Imagine if you were doing this interactively, you have to type out everything again once you made some changes, and that would be really tedious. So let's test out this function in our Python interactive prompt once you have satisfied of its correctness. So one way to automatically load the function without typing an import statement is to use the I flag or interactive flag and load this function. So automatically the GCD function has been loaded into the environment. You can see GCD is a function, and I can use GCD to compute, let's say, this number 17 and 51. Oops, should have used comma instead of dot. So 17 as expected, and for a large number, so you can see that this function actually does compute the GCD, and we have actually checked this correctness using the doctest module and we can do this automatically without tediously rewriting the code over and over again.